Hello everyone and welcome back. Today we are going to present how to make an alignment, a flatness, cylindricity and circularity on Calypso. So let's get right to it. Okay, so we have first the interface from Calypso. This is the interface. You can choose from here, create a new measurement plan. You can choose open a measurement plan, load CAD model, manage stylus systems and check settings. If you want to construct a new measurement program, then you will have to choose create new measurement plan or load CAD model. When you click on create new measurement plan, Calypso will give automatically a name for the measurement plan. So it will give automatically measurement plan number 1, for example. But if you take load CAD model, then it will take the name from the CAD model. So I usually take the name from the CAD model and then save it as I want to. So then you can import the CAD model. So I will import my CAD model now. Okay, so here it is. And you can do also that when you create a new measurement plan from CAD file load. Okay, first thing you will want to do after importing the CAD model is to go to CAD file and automatically healing. Okay, what this does is correct all the boundary curves or all the imperfections from the CAD model. Okay, so let's do that. Also, let's go to settings and set the boundary to black because it will be more visible. Okay, good. By default it's white, so now it's black, it's more visible. So I've made this drawing for you guys in order to make the flatness, the straightness, the cylindricity and the circularity right here. All the things that we've talked about until now on my channel, but I want to show you exactly how I do it in Calypso. When you first look at the drawing and you want to start creating a program, you must first look for the datums, right? But how do you look for the datums? Because as you know, these are the datums, but you can look at them and say, okay, so how do I do it? I do it BAC or CAB, or how do I do it? No, this is the tolerance reference frame, the only one that we have in this drawing. So we will use this reference frame to construct our alignment. And we can see here, for example, that we have datum A, the primary datum, and B minus C, which means that datum B and datum C are a common datum. So we will do exactly that. First, let's extract the feature, the plane. So go here, right here, down on the bar from below and select extract features. And just by simply clicking on a surface, Calypso recognizes and takes the plane. Okay, so this is the plane. We will call this datum A. Okay, good. Leave it like that and let's take datum B and datum C. So this one, exactly, again, extract features and select on the cylinder, and then you have datum B. Okay, datum B. Then select the other one and call it datum C. Okay, good. Now that we have all our elements to construct the alignment, let's go and do that. But first, remember that Datum B and Datum C were common datum, right? So, what you can do in Calypso is go to Features, Special Geometries, and you can make parallel cylinders. Okay, so parallel cylinders recall feature points Datum B and Datum C, and this will create exactly the common datum B minus C. Okay, and here we have also the diameters of the two cylinders, the positions of the two cylinders. So notice that we have x1, y1, z1, x2, y2, z2. Okay, and theoretical exact dimensions if we want to Cartesian or polar. But for now it's only interesting for us to see the common datum, to make the common datum. So we will define this as datum B minus C. Okay, and now we can go and make our alignment. So go to measurement, base, start alignment, standard method. We can choose standard method, 3D best fit method, RPS method, or 6 points method. But for now we will use standard method. Okay, so choose in the spatial rotation datum A to take 3 degrees of freedom. So you will take the rotation, but we will take the rotation on the z-axis plus in order for the z-axis to be in the up direction. Choose planar rotation datum B minus C and choose x-axis plus. X origin datum B minus C, y origin datum B minus C, and z origin datum A. Okay, so there you have it. We have our alignment. Okay, good. I think this is for the y minus, yeah. Okay, so now that we have our alignment, we have to create the clearance plane. So what the clearance plane does is tells the machine how to go around the part and not hit anything from the part or what's fixing it. So now I choose clearance plane from CAD model. It will bring 10 millimeters from all the edges of the CAD model, and I will choose, for example, 20 millimeters and say that it's fine. Okay, when you are happy, choose OK. Calypso will ask you if you want to change the clearance data, the clearance group. So what this means that the old ones wants to come from the z-axis plus. So the stylus will come from z-axis plus to measure all the features. But it wants to change the features to come from the first one. It doesn't change. The second one changes to y-axis minus. So it wants to come from this direction, from the forward direction. And the other one wants to be measured from x-axis plus. But I don't think it's necessary for us to do any modifications, so I will click on cancel because I don't want to make any modifications. I'm pleased with the stylus if the stylus comes from z-axis plus to measure all the features. Okay, good. Now we have our alignment, we have our clearance plane. We have now to go and check our nominals, because the alignment was not here at the beginning. So I want to check my nominal to see if everything is fine. So I have to make sure that the z-axis from the plane is set to 0, and I see that it's set to 0, it's fine. It has a length of 160 and 50 millimeters. We can see on the drawing that this plane has a length of 160 and 50 millimeters. Okay, so this is fine. Okay, I don't have any inclinations on the plane, that's also good. Let's make a measurement strategy on the plane. We can choose, for example, to measure multi-polylines from the CAD model. So it will go 1 millimeter from the edge distance, so from every edge distance, and make polylines from it. So I will give you an example. So let's say that we want to go 2 millimeters from the edge, and it will make from every edge that it encounters polylines to measure, to scan, right? So it will scan the polyline. We will not do it like this because okay, I want to make 3 millimeters. Yeah, 3 millimeters. And I want to delete this one. No, this one I want to keep, and this one. So let's delete it. Just press delete on the keyboard and it will go. Okay, so I think it's fine until now. Just go and you can, let's assume that the part is aluminum part, and you can work with the cookbook from size. And if you go in the cookbook, you can see that, for example, at page 92 from the cookbook from size, you will have the probing strategies for planes. So here it says that if we have a plane with the size from 81 to 250 millimeters, or 3.1 to 10 inches, we can use our speed of 10 millimeters because I'm using a passive sensor, right? So I will use a speed of 10 millimeters for a passive sensor, and a step of 0.31 millimeters, and we will generate 467 points scanned for all of the plane. We will do this because first of all it's a datum and it's important, and second of all we have to evaluate from the drawing the flatness of datum A. So good, let's do it like this. This was just for this polyline, the round polyline. Let's do it again for the big polyline. So maybe you can put a smaller number of points on this one because it's a small area, and choose on the biggest area the indication from the cookbook, but you can also do it like me, it's not a problem. When you go above a number of points, the results doesn't improve, doesn't do anything, but you can do it, it's not a problem. Okay, so step with 0.31, exactly as we did before, and we have 1278 points. Okay, good. So we have defined our plane. We can go and make the cylinders. Right, so for the cylinders we can go again in the cookbook, but we have to see if the cylinders and the nominals for the cylinders are fine. Okay, so let's see. I can see here some problems because first of all we have 54.999. Okay, 54.999. So we have a basic dimension here of 110. That tells me that it has to be 55. Okay, and 0 here. Okay, on the y-axis. Okay, and now it's good. And let's see the other one. 55 and 0 here. Good. Now go to Datum B, the cylinder, and let's see what the cookbook says. Right, again, you can work with your own strategies. Calypso doesn't imply to work with the cookbook, but if you have the cookbook and you are using metal parts, you can use the cookbook. It's very good for scanning, it's very good for filtering, it's very good for everything. Okay, so it gives you a good measurement strategy, but based on the research done by size. Okay, so maybe you will have different approaches for the strategies, for the filtering, for everything. Okay, good. So speaking of filtering, we haven't done any filtering on the Datum A, so let's go to evaluation, and here we have filter and outer elimination. Okay, so we will filter the plane. Okay, let's see what the cookbook says. Okay, so for a plane from 80 to 250 millimeters, we have to use 2.5 millimeter Gauss. Okay, so wavelength of 2.5 Gauss filtering method, and outer elimination sigma 3. Okay, include 5 adjacent points and a wavelength of 0 to 10 millimeters. Filtering and outlier elimination are done according to ISO standards, so you can use them. It's proven by size that these strategies are a good practice. Okay, good. Let's move on. So let's see what the cookbook says about shafts, because Datum B is a shaft. So you can go to page 58 in the cookbook and you can see exactly the measurement strategies. So we have here 3 ways of measuring. The problem is that you have to know exactly what you are measuring the part for, right? So are you measuring the part for a functional check, or are you measuring the part for a process control? So functional check is a quality process in which a part is checked against the designed function requirements. The check is for assembly purposes, prototyping, gauge replacement, incoming, outgoing inspection. The results will cover fitting matching situations, functional datums, in order to accurately report the deviation of the workpiece. Process control check will be run if the part under consideration is still within the manufacturing loop. This is to say that the part is still in the process of being made. This enables the operator to control production parameters, process flow, or calculate CG, CGK, or gauge R&R values. The process control check requires a robust, stable, outlier independent, and repeatable result. A typical use of a process check may be to show possible manufacturing deviation, such as worn tools, clamping error, location error, and so on. The results report information about the relative deviations of the workpiece during serial production. We will do it for a functional check. So if the diameter is like we have here, 1 time to 3 times smaller than the depth of the shaft, then we can use 3 circle pads. on the cylinder. So since it's 1 to 3 times bigger, because we have a diameter of 30 millimeters and a depth of 50 millimeters, then we will use 3 circle sections. Okay, good. So you can set here the start height and the target height. The start height 10 is this one from here, and 45, okay, and the third one is on the middle. We have to use a speed of 3 millimeters per second and the number of points of 1270 points. And we have to put the angle range from 0 to 380. 0 to 380, okay, so you can see here, so it starts from here and it goes, no, it starts from here and it goes like this, and comes and goes right through it and goes a little bit more. Why is this happening? The people that made Calypso thought that at first when the probe touches the part, it can have influences on the measurements. So it masks the first points and doesn't take them in consideration when scanning. So that's why we want to go a little bit further than 360 degrees in order for the circle to be complete. That's fine for me here, it's fine here. Let's set also here the filtering and the outlayering. Okay, so we want to filter this as 150 UPRs, undulations per revolutions, also Gauss method. As per, you can see here, it's per ISO 1661021 per 28. So it respects this norm. Okay, and the outlayer 3 sigmas. This is by default and usually it remains like this. Okay, and also this one is 5 adjacent points. What this means is if it's encountering something when it's scanning, for example dust, 5 points before and 5 points after that, it also masks, it also doesn't take in consideration. Maybe it's something there that it's not supposed to be and it's better to mask it. You can check it, you can redo the measurement if you want. You can see all of the information in the form of the cylinder after you scan it. If the form is big, you can go and see exactly if something is wrong there. If the form is okay, then I think it's fine. But be careful here because the form can be also deceiving. Some parts have big form deviation and it can misguide you. Go and see with your own eyes what the machine does, what the CMM does. Go and see exactly how it touches the part, if the stylus is with the right length, if the stylus doesn't touch with the extension. Go and see if there's any dust on the part, any grease or anything that can influence your machine. Check the temperature, check the humidity, check everything if you want to make sure that everything is fine. Especially when you are measuring for a functional check. 5 adjacent points, okay, and we can go and set here undulations per revolution. You will get this message each time, so be very careful. It's warning you that at least one strategy of the feature must be a circle path or helix so that the prefilter can be specified with waves per revolution, otherwise the prefilter is not executed. So keep this in mind, it will not execute the prefilter if you will not have a circle path or a helix. Okay, it isn't our case, so we will set this from 10 to 5000 undulations per revolutions. Okay, apply, okay, everything looks fine, go, we can move on. And now for the other one, since the drawing says that we have two cylinders, same height, same diameter, as we see here. Then we can copy the strategy, the measurement strategy, to be more efficient in our work. So we can do this with the format painter, so transfer format. You will have to check first the feature that you want to transfer the format from. So Datum B, transfer format, measurement strategy, and evaluation settings. So first let me show you. Datum C has only two circle paths right here, and it doesn't have any evaluation, any filter or outlier elimination. And Datum B has three circle paths and everything that we've done until now on it. So if we check this, if we check evaluation settings and measurement strategies, press Ctrl on the keyboard and select Datum C. Then select OK, and we can see that Datum C now has the same strategy as Datum B and the same evaluation, filtering and outlayering. Okay, good. Now that we define our datums, we define our measurement strategies for the datums, we don't have to take in consideration Datum B minus C, so the common datum, because it's a recalled feature, right? So it's a recalled feature right here. Okay, it's on 0, 0 and 5, that's fine. Okay, good. And now that we have this, we can work on the drawing. We have the alignment, we have everything, and we can work on the drawing. What we want to do again, and what I usually do, not on all the parts, but for example on parts that I know that are not stable enough, right? So usually I work with this method almost each time. So I go on the measurement alignment and check on the loop, and I insert the 5 loops. Just insert the formula. The formula is base system. So the base system, open bracket, close bracket, point value A smaller than 0.0. You can vary it here. You can go, I usually go 0.01, but depending on the drawing, right? So I can go on the drawing, I can see that the smallest tolerance I have is 0.05. So if I go 0.01, then I think I'm fine. I'm okay, I can work with this. If the alignment, if my alignment goes this stable of 0.01, then it's fine. Now we have the alignment, we have everything. Let's go on the drawing and see exactly what do we want to measure. So first of all, let's say that we want to measure the flatness of Datum A. So we already have Datum A right here, and we can go to format location, flatness, and evaluate flatness of A. Datum A, and set the tolerance of 0.05. Okay, good. Then we can go on the drawing and see what we want to do again. So we want to do the straightness of this side. So it's the straightness of this side. It doesn't say exactly where it wants to make the straightness, so you can choose exactly where you want to make the straightness, but we will leave this for now. We can evaluate also the cylindricity of the two cylinders because we already have them. So we can evaluate the cylindricity. Go to form again, format location, and go to cylindricity and select Datum B 0.05. You can go and say cylindricity on B, and also copy it and paste it, rename it at cylindricity datum C, and select datum C 0.5. Okay, good. So as you notice, we already have 3 evaluations from the drawing, so 3 characteristics we already done from the drawing. We can make also some more. We can make also the diameters of the cylinders, for example. So we can go in the features, we can go to datum B, we can check diameter, go to see the tolerance is 0.2, so we have upper tolerance of 0.2 minus 0.2. So I am going to set here last input to remember what I inputted last time. Okay, and now I want to make the same thing, and it's already done. Datum C. Okay, and we also have the diameters of the datums, and we already have 5 characteristics evaluated in Calypso. This is why I like Calypso. Everything is very straightforward, everything is very easy from my point of view, but you have to be careful because Calypso helps you a lot and you can make mistakes if you are not careful. So let's make the straightness. So let's choose a line right here. You can go here and you can define a line on a plane, for example. And I will try to go on the middle of the plane. You can also check the distance if you want to. With Calypso, you can go here to below bar and distance check, and go and click on it, and it will do, you click on the surface and it will do 2 points, and it will do a 3 polar distance. So notice that we have 30 millimeters from this surface to this surface. Okay, just remember to delete the points because you don't need them, to delete everything because you will not need them. Okay, so we have the line, and notice that the line is not so straight, so I will correct the nominals again. So I want to have a straight line. I want to be at 15 millimeters from the alignment, from the origin from A, to be exactly in the middle. And the length, the depth. Okay, the depth is 137, but we will make it 140, 70 millimeters. And now I know that it will have 10 millimeters from here and 10 millimeters from here because the surface is of 160 millimeters, right? 160 millimeters. So we have 10 millimeters from here if it starts from 70, so 70 from the middle, right? 70 millimeters in this direction, which leaves 10 millimeters, 80 millimeters from here, and it has 140 in order to have 10 millimeters from here. So we are safe from the edges and everything. So notice that I calculate everything when I program. If you do it like this, then every part you will measure will be measured the same. Okay, so keep this in mind, calculate everything, and also work from the closest surface to the closest surface. What we are doing now is basic programming, not going in depth. We will go a little in depth on the holes and on small surfaces, but not very in depth. So keep this in mind. Okay, let's move on. Let's set the strategy on the line. Okay, so on the line we will keep the strategies from the plane. So since we have a plane of 160 millimeters, we will use again the speed of 10 millimeters and the step of 0.31 millimeters. Okay, good. So we will have 452 points. Again, go and filter it, outlayer it, close, and outlayer again 3 sigma 5 adjacent points, and from 0 to 10. These are the filtering and the outlayering. Okay, good. So we have the line, and now we can go and make the straightness 1 of the line, and we have a tolerance of 0.1 on the straightness. Good. Now we have to do also the circularity, right? So notice that the circularity is put on. Okay, so let me also tell you a secret. On the PDF, and only on the PDF, if you press Ctrl and 5 on the keyboard, so Ctrl 5 on the keyboard, the boundary will be thicker, right? So the boundary will be thicker and you can see better on the drawing. Maybe you know this, maybe you don't, but I hope it will help you. Okay, so notice that we have a diameter that we want to do at 10 millimeters from datum A. Okay, because this is datum A, right here. Okay, and it will have this diameter of 36.53. Okay, and here also it wants to make the roundness. Okay, so how do we do that? Well, we will use formulas. Okay, so first of all, let's define circle on a cylinder, right? So just click on it and notice that Calypso, notice that we have a cone here. So if we want to say to Calypso where exactly we want to make the circle, we can go here on this icon from the diameter and say that we want to take it at 10 millimeters from datum A, and it will calculate the diameter automatically. So it says that here we have a diameter of 36.473. Okay, the drawing says that it's 36.53. Okay, so we will respect the drawing, 53. Good. Also correct the nominals. If they are not correct, then correct them. So I've done everything according to the drawing. I don't care what the CAD model says. The CAD model may be wrong, may be executed wrong, may be a problem when exported, maybe, I don't know. Just keep in mind that we as programmers work from the drawing. The CAD data is here only to help us work faster, work easier, but we work from the drawing, okay? So keep this in mind, okay? Set the nominals, everything looks fine now. We have the diameter, we have everything here. So now that we have datum A from here, we have datum A here, the nominal, the basic dimension is respected, it's fine. But maybe this plane was not a datum, and the drawing asked you to do a diameter on a specific level. What you can do is take the plane, but only take it from the surface near the circle, right? So make a circular path, right? So take the plane, go to strategy, make a circular path of the plane. Notice that it's already there because it's simpler for Calypso to calculate it like this, because this is also where the origin is. Okay, set the diameter of the plane at 47, because I think it's fine like this, because we have 50 millimeters, so I think we are safe. Yeah, we should be safe. We can go to 46.5 and we are safer now, and set the nominals to 0. Okay. Also the speed here, it's way smaller because it's a smaller surface, so we have 5 millimeters per second, and here we can leave it at 0.31. But we can also, because this is only a plane that helps us define the circle, we can do it, for example, with a number of points, and we can ignore the speed and everything, and we can do it by 7 points, for example, or 5 points, for example. It's fine. Single points, and it ignores the step width, the speed, and expectant tolerance. Okay, so it's fine like this. Notice the points right here: 1, 2, 3, 4, 5. Okay, yeah, that's fine. Okay, good. Now that we had this plane, and we wanted to make sure that the circle is done according to that plane. So what can we do is, first of all, after we measure it, go and right click in the box that represents the axis that you want to use to go on the level, to use the basic dimensions. So right click, formula, select plane 1, z-axis, and say that you want to go from this plane minus 10 millimeters below. And it's exactly like this. When a formula is applied on Calypso, you will see it with yellow, as you see it here. Okay, so this is the way you can do the measurements with the formula. I usually take also the inclinations of the plane. So what I do is go to inclination. This represents the inclination on the axis, right? So the rotation that the part can have. So I go here and use exactly the formula again. Take A1 and A2 with the formula from the plane. Okay, so now again it takes the formulas from the plane, A1 and A2, with the rotation and everything. Okay, but I will not use this because I don't need the plane, right? I only showed you the example, but I don't need the plane because this is datum A, and the datum knows, from the datum it knows exactly where to go. Yes, you can use it if you want to work from close surface to close surface, and it's recommended, but again, we are doing basic programming, not advanced programming here. Okay, good. Let's set the strategy again for the circle. So we now have a circle on a hole. We can go to page 18 in the cookbook in 26 to 80 millimeters. So we will do 5 millimeter per second scanning and 1270 points, and again 380 degrees. Okay, filter it, outlayer it, 150 goes, and include 5 adjacent points. Again, ondulations per revolutions 10 to 5000. Okay, good. Good. Now we can do also the roundness, right? So roundness, circle 1, 0.1. Good. We can also do the diameter from the circle if we are here. Diameter 0.1. Okay, so clearly on the drawing there is a mistake. So leave a comment below and tell me if you notice the mistake from the drawing. I made this intentionally to see if you understand what I explained until now. Okay, so we have the roundness, we have the flatness, we have the straightness, we have the cylindricity, we have everything that we want to have. Our program is done. Okay, good. We now have to measure the part, but I want to show you something else. I want to make this dimension from here to show you something. Okay, so this is a bonus from my side. I want to show you how to find a very thick surface and to make sure that the program can measure each part exactly the same each time. So we have to make our surface from here in order to evaluate this distance. Okay. First of all, let's define an exterior circle. I think at 2 millimeters from this side it will be enough. So let's go to 48 millimeters because let's go to 47, 3 millimeters. Yeah, it's fine. And go and again set the nominals as they are in the drawing. Okay, 55. So again, how do I calculate the nominals? Notice that we have a basic dimension of 110. If you divide that by 2, it will be 55. So I know that this cylinder is at 55 millimeters and this one is also at 55 millimeters. Okay, so that's how I know this. Okay, the drawing tells you everything. Just look on the drawing. If there is something missing from the drawing, then you can use the CAD model, but only then. Okay, so 3 millimeters, okay, and again we will do an interior one of 3 millimeters again. Again, 47. Let's correct the nominals. Okay. Now let's set the strategy, because again it's help circles. We will not use scanning, we will use 7 points, individual points, and it will be fine. And for this one we can use also 7 points, and we will use the transfer format but without the evaluation settings because we don't need it. And we have 7 points here as well. Good. Let's see, 30 millimeters diameter and 26 millimeters diameter. Okay, so now we took the surface from here And we will go to strategy and construct a circular path. So this strategy will work only for circular paths. If you want to use this strategy and find thick surfaces but they are not circular, then you will have to use other strategies. Okay, so it's a plane of with a length of 29.99, so almost 30. We will go again on the measurement strategies from the cookbook and see what the cookbook says. So again, we can use a scanning of 5 millimeters per second, step of 0.1 millimeter on this case. Okay, and also we will use this as to 380 millimeters. Okay, good. So we want to measure each time in the center of the surface, right? So how do we do this? So go to diameter and use again a formula. This time we will take the diameter from circle 2 plus the diameter from circle 3. Use brackets, set everything to brackets, and divide it by 2. Okay, so Calypso uses mathematical formulas, so keep this in mind. You can use this whenever you have circular paths on a thinner surface and you want to make sure that you touch in the center each time. But you also want to take in consideration the axis from the plane, the x-axis and the y-axis in this case. So take the x-axis from circle 2 plus the x-axis from circle 3, set it again in brackets and divide it by 2. And also for the y-axis, take the y-axis from circle 2, the y-axis from circle 3, set it in brackets and divide it by 2. Now that we have this, our circle from here, our circular path from here, from the plane, will go each time in the center of the surface. Only if the circle from here and the circle from here is not concentrical, we can have some problems, but this is, I don't think it will be the case in much of the cases. Okay, so it's fine like this. Set okay, 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 and evaluate, filter and outlayer the plane. Okay, so for this plane we have 0.8 millimeter wavelength cause and an outlayer again with 5 adjacent points, and from 0 to 10 millimeters wavelength. Okay, good. And we want to make this one, so extract the feature. We can take the plane from here. We can make again a strategy, circle path strategy, set the diameter of 20, I think it's fine, speed 5 millimeters, 0.1, and also for this one set formulas to respect the center of the circle. This time we will need only the circle from inside, not the one from the outside. Okay, so the circle from inside is circle 3. If you don't know what circle is the inside circle, then you will have to get out and check. Do not make mistakes when you input the formulas. So again, circle path formula, circle 3, x-axis and y-axis also from the circle 3. Set this to 380. Okay, okay, okay. Good. Now we can make the distance. Go to size, go to distance. I usually work with Cartesian distances. And select. In Calypso you will have to select from the smaller element to the bigger element if you want to measure correctly a Cartesian distance. So in our case we go from plane 2 because it's smaller to plane 1. 30 millimeters. Check the tolerance. 0.1. Okay. Cartesian distance 1, leave it like this, or change it to wherever you want. You can change it to 1, you can change it to cylinder, whole cylinder distance, wherever you need, and okay. And now we have everything. We can go and set the styluses that we want to work on. So I want to work on this with only one stylus. So I will choose a stylus of 70 millimeters in depth. So the extension is 70 millimeters and the diameter of the stylus is 3 millimeters. So I will use this stylus to measure my elements because this shaft is 50 millimeters, so I'm safe with 70 millimeters and 3 millimeters. So maybe if the parts are deviated, then I will have to choose 70 millimeters with 5 millimeters in diameter because I will not risk to touch the shaft with the extension, but for this example it's fine. Okay, the stylus we want to use one which is A0 B0, so it's a straight one. Okay. And also we want the clearance group to go from the z-axis plus. Yeah, I think it's fine like this. Okay. Good. Now we can run. When you run it first time, run it in manual mode. Okay, so just run it in manual mode and let's set the order from the feature list. Let's say that we want it in normal and set the speed to 200. I think it's enough. Leave it like this and start. Now it's going to measure everything. And there we have the standard report from Calypso. We can also choose detailed view and we can see the flatness right here. We can see the cylindricity. We can see the cylindricity from Datum B, Datum C, the straightness, the roundness, and everything that we want to see. Okay, so everything looks fine. There you have it, guys, the first program that I wanted to show you in Calypso. Remember, this is basic programming. Remember that you will have to do a lot more than this when you actually work on the machine. You will have to use whatever it is necessary for the CMM to find your part each time, wherever the case may be. I hope you enjoy my content. I hope you subscribe if you did not until now. Do it. Leave a like if you like what I'm doing, and until next time, have a nice one.